Hi all. So I'll be going through this P5 2023 pay Chun paper, which is a term 2 weighted assessment. Okay, so let's begin. So just take note that no calculator is allowed as per the instructions here. Alright, so first question, the diagram shows some circles and triangles. Find the ratio of the number of triangles to the total number of circles and triangles, expressed in simplest form. So it's a very straightforward question. What you just have to do is to count the number of circles and the total. Alright, so first thing, whenever they tell us they want ratio of something to something, I will start off by writing what the question wants in terms of that ratio. Okay, so they want triangles to the total. So I'll start off with triangles to the total. This is the title that I will first pen down. So count the triangles, 1, 2, 3, 4, 5, 6. So there are 6 triangles. We park down here. Total, just count everything. So 1, 2, 3, 4, 5, 6. That's 12, 13, and 14. So this will be 14 shapes altogether. So just simplify the ratio. Both numbers can divide by 2. So if we divide by 2, that gives us 3 is to 7. Okay, so this is the simplest ratio. Okay, next question 2. So PQR is a triangle. PQR. So do not get confused by the other dotted lines that creates other triangles in this case. Okay, because all these other dotted lines could be more like a reference point for something else. So they say given that PQ is the base of triangle PQR. So I'm just going to highlight the base. Okay, so PQ serves as the base of triangle PQR. So they said name the related height of triangle PQR. So this is a very commonly tested question. They are basically trying to test you to see whether you are able to identify the height that is corresponding partnering with the base that is provided. Okay, so remember the two conditions for the height to happen. The height must be perpendicular to the indicated base. That's number 1. Okay, number 2 is that the height must be touching the corner of the triangle that's opposite that base. So for number 2, since the base is PQ, notice that the corner opposite PQ is points up. R is opposite your PQ, so definitely your height must be dropped down from R. Okay, so I think it's pretty obvious already. Your height to be perpendicular, you see this right angle here. So it should be RW. RW will be perpendicular to PQ. RW, okay, fulfills condition 2 also, whereby it drops from the corner that's opposite PQ. Okay, so your height will be this one, RW. So don't worry if you think that, how come the height is not exactly touching the green color base? Okay, it need not touch each other. The height and base need not touch each other. All right, they need not be in contact with each other. They just need to fulfill the two conditions that I just mentioned. Okay, question 3. The solid below is made up of unit cubes. How many unit cubes are needed to form the solid? Okay, so how many cubes needed to form the solid? Basically, they will just want you to count the number of cubes. All right, so of course, let's count it systematically. All right, notice that the cubes are very neatly arranged. No strange arrangement that makes it difficult for you to count. All right, it's all pretty neatly stacked up together. So we can actually count in terms of like the rows and columns. Okay, so maybe let's start off with this part first, this row, or maybe I should say this column of cubes. So if you count the top, there's 1, 2, 3. Bottom is, not bottom, sorry, the height wise is 1, 2, 3, 4. All right, which means that this column of cubes, there should be 12 cubes. Okay, so 12 over here. All right, which means that this is also 12. Okay, why 12? Because 3 times 4 lah. I'm doing quick counting. Okay, 3 times 4. That's 12 cubes per this column. This one also 12, 12. This one also 12. Okay, this one also 12. So the only one that's the odd one out is this last one. 1, 2, 3, 4. This one is 4. Okay, so now you just need to add up all the numbers. 12. There are 5 sets of 12, right? 1, 2, 3, 4, 5. 5 sets of 12. Okay, then just plus the 4. That should give us 64 cubes. Okay, this is how we do quick counting without having to count each cube, one by one. Don't have to do that. Okay, question 4. Draw the cuboid below on the isometric grid. So notice that there's a point A here, and they have indicated this here as point A. So make sure your point A, these 3 lines that connects to A must be connected the same way here also. Okay, so when they say draw the cuboid below, basically they just want you to redraw the cuboid. All right, so how do we redraw it? So in this case, if you look at the maybe let's do the height first. So notice that the height is a 3 cm height. Okay, so we're just going to take the gap between 2 dots as 1 cm. So that means I connect 1, 2, and 3. Okay, so this is my height. Now the next one would be, I would think I will do the breadth from here. When I say the breadth means this part here. Okay, this part. So we know that the breadth is 3 cm, so this will be 3 cm as well. So if we look at starting from A, 1, 2, and 3. Okay, so connect like this. All right, which means that now it'll be easy for me to connect the other height of 3 here. So in this manner, then we can connect this. So I've drawn one face of the cuboid already. Okay, now I'll go on to connect this 4 cm. So it's a 4 cm, so 1, 2, 3, 4 up to here. Okay, please use a ruler when you draw. Okay, for now, because I'm drawing it on the screen, I can't exactly use a ruler to help me in drawing. All right, so I'm just drawing freehand. Okay, so same over here, the breadth here, I will connect 4 gaps. 1, 2, 3, and 4. All right, so there you go. Now you can connect this 1, 2, and 3. All right, so now I can drop the height down to 1, 2, 3. Okay, and finally connect this. All right, I think let me redraw this. Okay, yeah, so there you go. Okay, so make sure that the final result really does look like the cuboid on the left-hand side. The lines should be parallel. What do I mean by that? That means this, they're all parallel. Breadth, 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 parallel. Okay, length, length, length are parallel. This is how you do a double check. All right, I'll go on to question 5. Simplify the ratio to the simplest form. So 36 to 72 to 54. Okay, all of them can be divided by 6. Okay, so I'll divide by 6 to them. All right, so divide by 6, this will be 12. Divide by 6, this will be 9. Now check if you can still further divide. In fact, you can still further divide all this by a 3. Okay, so actually, if I had observed earlier, which I didn't actually, if I had observed earlier, I could actually have divided all these original numbers by 18 straight away. Okay, highest common factor will be 18 because 6 times 3 6 times 3 is 18. So all of them can be divided by 18. Right, but because the first number that came to my mind just now was a 6 among all this. Okay, since I can't use a calculator, I'll just do a manual division in this case. Let me just write this near to the arrow. Okay, so yeah, let's go on to further divide by 3. So this will be 2, 4, and 3. Okay, and that would be my simplest form, 2 to 4 to 3. Question 6. So there are 4 triangles here, A, B, C, D. It's a bit dark, like you can see it. So state the 2 triangles that have the same area. Okay, so notice that they are all made up of different shapes and sizes. It's a bit difficult to tell straight away which ones have the same area. So what you have to do is to probably calculate out the areas for each of them. Okay, so let's take it as this is 1 unit of, the square side here is 1 unit. Okay, so let's talk about the base of A. Base of A, definitely I will use this, 2. Okay, the height of A, notice that it's here, dropping down from here to downwards. Okay, so if I were to drop the height down, this is the vertical height. And notice that the vertical height has a height of 3 square sides. Okay, it's equivalent to 3 sides of the square. So basically this will be half times 2 times 3, half times base times height. Okay, let's do B now. B, the base would be 2. The height will be here. Okay, so the height will be here. So like I said, the height need not touch the base. They just need to drop down the perpendicularly to the base, and it must drop down from the corner that's opposite the base. Okay, so this will be 4. Base is 2, so half times 2 times 4. And for C, I will treat this side as the base. So you might want to rotate the paper if you can't tell. Okay, so 1, 2, 3 is the base. Height will be here. Drop it down from here. Notice the height is a little bit special because the height in this case, it doesn't take up a nice full side of the square, especially this corner here, this part here. All right, so for this part, maybe we can take it as like 2.5, maybe, because like midway, sort of midway on along one side of the square. Okay, so it's like one side, two side, and 2.5. Okay, let's just take it as that. So half, the base is 3, right? Half times 3 times 2.5. Okay, for this, it may be a little bit more challenging to calculate. Let's just leave it as it is. If you don't calculate out, it's fine because I think it's quite easy to compare the equations already to see which one have the common 2 areas. All right, finally, let's do D. So we have 1, 2, 3, 4. This will be the base. So half times 4. Height will be here. Okay, this will be the height, which is a 2. Okay, so I think there you go. It's pretty obvious. You can tell already, right? The one with 2 common answers is these 2, B and D. So you don't even need to calculate for C actually. Okay. Okay, question 7. Find the volume of the cuboid. Okay, so volume meaning length times the breadth times the height. This is very straightforward. Length is 9. Breadth is the 5. Height is a 3. Okay, so this will work out to be 135. Okay, this is on ratio. So 56 to something must be equals to 24 to 36. All right. Now, 24 to 36, you notice is not even in the simplest form yet. All right. So maybe what I suggest us to do is I'll just simplify 24 to 36 at the side here first. Okay, because right now, if I compare 56, I ask myself like 56 divide by what number to give 24? There's nothing actually. I can't divide anything to 56 to get 24. So the only way to continue from here is to simplify 24 to 36 first. All right, so if you simplify this, this will actually be, both can divide by 12. So this will be a 2 and 3. Okay, now, so finally, using this 2 and 3, all right, I can now park it here, 2 to 3, this one. Then it'll be easier for me to tell the division already. Okay, so 56 divided by what give me 2? So 56 divided by 28 actually. All right, which means that now we have to perform something divided by 28 to get 3. So if you do the opposite, the reverse will be 3 times 28 to get the blank. right? Which works out to be 84. Okay, so basically when you're given a ratio like that, and you notice that okay, 56, I can't divide anything to give me 24, then what you do next is to observe to see whether you can make adjustments to this ratio first. Usually this ratio usually might not be in the simplest form, hence you struggle to work out a number for the division immediately. So what you should do is go ahead and simplify this ratio. Normally that's the case. Simplify this ratio, then you can now, smoothly be able to figure out what's the number to divide to get to the simplest form. Okay, yeah, so that's the approach. Okay, next one, find the area of the shaded triangle. So shaded triangle, identify which side would you like as the base first. I think the base, of course, the most helpful will be the 9 cm, okay, because I see a right angle here along this base, okay, so most likely that will be helpful. So then where's my perpendicular height? Perpendicular height again would be dropped down from the corner opposite the base, and it must be, like I said, perpendicular to the green base. Okay, so there you go. We have identified 9 as the base, 8 as the height. So we can apply that half times 9 times 8. Now, without a calculator, how would you perform this calculation? Okay, so without a calculator, you do the cancellation method. 2 and 9 cannot have a common factor, but 2 and 8 can. So this one become a 4, because 8 divided by 2 give me a 4. Okay, so 4 times 9 times 1, this will work out to be 36. Okay, question 10. So Christopher and Sulin share some stickers in a ratio of 5 to 9. So first, I'll write down the ratio. Christopher to Sulin is 5 to 9. Always record this down first. Sulin have 45 stickers. So how many stickers did Christopher have? So if Sulin have 45, just need to make use of the S here, which is 9 units. So you can read this as 9U. So you can say 9U will be the 45 stickers. Of course, work out 1 unit. Now we want Christopher. Christopher will be 5 units. So just work out 5 units from there. Okay, so that will be 25 stickers here. Okay, question 11. The diagram shows some unique cubes in the box. How many more unique cubes are needed to fill up the box completely? Okay, so right now, notice that the cubes are arranged in some strange manner. It is unlike one of the previous questions previously, whereby they are all arranged in stacks, very neat stacks that makes it easy for us to count. This one, some more the difficulty is finding out how many more cubes to fill up completely, meaning the spaces that exist now, you want to find out how many more cubes to fill up those spaces. Okay, now when you meet or encounter such a question, what you should do is don't look at the space. You should first count what are the cubes that already, how many cubes already exist inside the box. Work on that first. Okay. And the next thing is find out how many cubes can it fill up the whole box completely. That means how many cubes will occupy everything in the box, the maximum capacity. Because that will be easy to count also. So once you have these two things, you can then just subtract. When you subtract, basically you're working out how many more cubes to fill up the space. That will be a lot easier, this approach. Okay, so let's work on that first. So let's work out how many cubes are there now first. Okay, so if you count 4, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so right now there are 15. Let me just double count. Okay, 4, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there are 15 cubes. All right, so now in the box, there are 15 cubes. All right, maximum capacity. I'll just write down the word capacity. Capacity means the whole box, how many cubes can fill up the whole box. Now, very easy. Just look at the length, breadth, and the height. Okay, so lengthwise, you notice that lengthwise, you count those that are already arranged here. So 1, 2, 3, 4, 5, 6, 7. So lengthwise can fill 7 cubes. Okay, this lengthwise. Let me just draw the arrow. Okay, now we're going to count the breadth-wise. So breadth-wise, easy lah. Okay, breadth-wise, I know it's 3 cubes. All right, and for the height-wise, this will be 4 cubes. If you look at this one, 1, 2, 3, 4. All right, so looking at the length, breadth, and height that I've counted based on the number of cubes, we can now work out the full capacity, which means that I just need to use length times the breadth times the height to find out the maximum number of cubes this box can fill up. Okay, so 7 times 3 times 4. This will be 84 cubes in total. So maximum the box can fill up 84 cubes, but now in the box there are currently 15 cubes. So now you can find out how many more cubes to fill up completely. Just take the difference. Okay, so that will be another 69 more cubes. Okay, question 12. So the figure is made out of a 12 cm square, ABCD, and a triangle DEF. E and F are the midpoints of AB and BC respectively. Find the area of the shaded triangle. So if you notice the shaded triangle, I can't really work out the area of this triangle straight away because I know nothing about the base nor the height. I don't know what are the measurements for any of the 3 sides of the triangle. Okay, which means that I probably then have to work with something else first. All right, so the something else that I can work with likely would be the unshaded triangles that I see here. The unshaded triangle, there are 3 of them, 1, 2, and 3. They all surround the shaded triangle, and they are all existing within the whole square here. Okay, so the approach would be later, once I found area of unshaded parts, I just need to use the area of the whole square minus of the unshaded to get my final answer that address the shaded part. Right? So what you can do is you can name this as triangle XYZ first. All right, so that later when you do your labelings, you might have an easier time. All right, so I'm going to work out area of triangle X now. Okay, so for triangle X, now the good thing about, okay, I forgot to mention, the good thing about working with unshaded parts is that all these unshaded parts, they are all right-angled triangles. So it makes our life a lot easier. This is a right angle, this is a right angle, this is a right angle. When you have right angles in triangles, identifying base and height, very easy, right? Unlike the shaded part here, no right angle, then it's even more difficult to work out the base and heights. Okay, so let's start with triangle X. So the base, you can treat AD as the base, 12. The height, of course, following this right angle, height will be AE. So you need to find out what is AE first. Now that's easy because they say E is a midpoint of AB. So if E is a midpoint, it means that this AE here is a 6 cm. 12 divided by 2. All right, so base and height are there, so half times 6 times 12. Okay, so this works out to be 36. Now let's do triangle Y next. So triangle Y, the base and heights will be this one, EB and BF. EB, I also know is 6. Now F is also the midpoint. Okay, F is also a midpoint of BC. So BF No problem, also 6 yen. Okay, so triangle Y, half times 6 times 6. Triangle Z, the last one. So FC is the height, DC, 12 cm, is the base. Okay, how I know this is 12 also? Because this is square. So if here is 12, of course, DC is also 12. Right? So half times 12 times 6. You can actually use back the answer from this one. Half times 6 times 12 is the same as half times 12 times 6. Okay, so 36 here. Right? Okay, so right now what we're going to do next is we can add up all this. Okay, so total unshaded parts. It's 36 plus 18 plus 36. So the total unshaded parts is 90 for the area. And like I said earlier, what we want to do next is to find the area of the whole square. Whole square will be just the length times breadth, 12 times 12. And finally, we can find the shaded part. So just take the whole square minus the unshaded part. Okay, so that means 54 will be your shaded triangle. Okay, question 13. So there are 90 students in a school choir and there are 24 fewer girls than boys. Find the ratio of girls to boys in the school choir. Now be very careful for this. It seems like a very easy question, but a lot of students, you failed to take note that this 24 is the difference between girls and boys, and this 90 is the total students. So some of you just take like 90 minus 24, and then you tell me the answer is like the number of girls. But that's not true, because this 90 is not boys. This 90 is the students, the total students. Okay, so actually, since you are given total, let me maybe just put a note down. All right, so this is the total. This is a difference. When you are given just total and difference, recall back to your lower primary concepts. Just total and difference given, you can use a simple comparison model to solve for your girls and boys. Okay, so they say there are 24 fewer girls than boys, so boys should be larger. So this will be your 24, right? And you have the total students. Total students is 90. So there you go. You have to find out 2 units first and work out 1 unit. Okay, so it's a 2-step problem in this case. 90 minus 24. So this will be 66. And then 66 divided by 2. So 33 means the number of girls, because that's 1 unit. Okay, you have to find boys also because they said ratio of girls to boys. So for boys is 1 unit plus the 24. Okay, so now we know there are 57 boys. So now you can write out a ratio of girls to boys, 33 to 57. And I believe this is the simplest form already. Oh, sorry, this is not the simplest form yet. Both numbers can divide by 3. I just noticed. Okay, both numbers can divide by 3 because 3 is also a factor of 57. So 11 to 19. Okay, question 14. So the solid figure is made up of 28 unit cubes, and you need to draw the front view and the side view. Okay, quite a bit to draw. So let's draw the front view first. All right, so I'm just going to highlight out what constitutes the front view. All right, so your front view, you should have, okay, this one also. Okay, this one also. Okay, and don't forget this one, the front here and here. All right, yes. So I hope I didn't miss out anything. Let me just double check. So front view should be those that are colored in blue. Yeah, that should be it. All right, so let's draw that out. Okay, so this, okay, so when you draw, right, do it systematically. You can start off with the most left-hand side, okay? Just need to count. Don't care about whether the cube is it protruding out or not, all right? Because anyway, when you draw front view, it will just look like a flat. It's a flat figure diagram, all right? So you just count the number of squares that you've colored on the left side. So 1, 2, 3, 4, 5. Okay, so 5 squares on the most left. So I'll start off with that. Okay, next one will be here, 1, 2, 3, 4. Okay, and take note where to put the four squares. The four squares must be placed nearest to the bottom lah, because these and these are on the same ground. So here, all right, and the next column, same four squares also. All right, and this side. Okay, so this side, just take note. Oh, okay, my bad. I'm so sorry. I just realized something. So you know this square here, right? It's actually hidden already. This square is hidden behind this, so we shouldn't count this square, in fact. Let me just erase that. Okay, so this one, no, because this one should be hidden behind this one. So if you count based on this, will be 1, 2, 3, 4. Okay, so the same 4 again. Okay, and lastly, the last column, 2 at the bottom. Okay, that's it. So this is your front view. Okay, next will be the side view. So I'm going to use a green highlighter to color the side view. Okay, side view, definitely this will be included. This row first. Okay, and of course will be here, here, here. Okay, and of course this also. Okay, that should, oh, okay, and also be careful. We also have this one here. All right, because this one is at the second layer. Okay, we call this bottom layer, then this is stacked on top of the bottom. So this is the second layer. So this second layer is exposed through this opening here because there's no blockage here. There's nothing to block that. So this should be considered as part of your side view also. All right. This bottom two, no, because this bottom two will be hidden by these two cubes. All right. So that should be all. Let me just double check. Okay, yeah, that should be all already. Okay, so we're just going to draw that out. Let's start with the most left-hand side here. So 1, 2, 3, 4, 5. Okay, next column will be 4 here. 1, 2, 3, 4. Next one, just 1. Okay, and lastly, the last column, you should have 2, 1 and 2. These two falls within the same column of squares to draw. Okay, that's it. All right, so front view, side view, this is how it looks like. So this is definitely a more complicated front view, side view to be drawn for such a question. Usually they give a smaller solid, but this is one of the more challenging ones. Okay, question 15. So the figure EFDGH is made up of two identical triangles, EFD and EFH. So they are overlapping. Okay, those two triangles are overlapping. And the area of figure EFDGH is 168. So everything in shaded part here you see is 168 cm2. That's the area. And they ask, what is the area of triangle EFG? So we want this small overlapping triangle part. Okay, so how do we start off from here? So if you look at these two triangles, okay, maybe what we can first do is we are going to focus on one triangle first. When I say one triangle, I'm actually referring to the one that's stated in the question, EFH or EFD. So I'm highlighting EFD out now. Okay, I know you can't really tell because of the black ink is really pigmented here. Okay, so actually this, I'm highlighting this whole triangle EFD. So we're going to work out area of one triangle EFD since the measurements are given. And then you can use the 168 to minus EFD so that you can get HGE. Okay, so this should be the right approach to use. Do not try to say 168 divided by 2. Because you say two triangles is 168. Cannot do that because 168 is including the overlapping part. Things are inaccurate already because of that. Okay, so never ever do that. So you should work out area of one triangle first as per what you observe. Okay, so triangle EFD. Let's do that. So EFD, we have the base and height, right? Base will be 14. Heights will be 14 also. So half times 14 times 14. So this will be 98. Okay, so now to find triangle HGE, I can use my 168 minus 98, which makes it to be 70. Okay, so just take note, your 70 will be this part. And that also means this part is also 70. Because it's two identical triangles, hence these two, and they share the same overlapping part here, hence these two remaining parts must be the same. So 70 is this one and this one. Okay, let me just... Okay, so the one that I trace out in red, my red ink, is 70. Now, notice then you can easily find EFG already. Because I know this, and this adds up to 168. I repeat again, 168 is made out of three parts. This red triangle, and also second red triangle, and the last triangle EGF. So three parts constitute 168. So now to find your EFG triangle, you can just use your 168 minus minus the 270s to get the answer. So the answer will be 28 square centimeter. Okay, question 16. So James formed the first four solids using identical blocks of cubes. He added a layer to the next solid as shown below. Okay, so observe how the cubes are arranged. All right. So if you observe from the diagram, okay, because now we are dealing with cubes, not just squares, okay, it makes things a little bit more challenging. But luckily, the stacks are pretty neatly arranged. So you notice that every row of cubes is 1, 2, 3, 4, 5 cubes. It's always adding on like 5 cubes. If you add on one layer, like one layer of cubes, is always 5 in that layer. All right. So in this case, I will first observe the front squares first. I will not care about the cubes first because I personally feel that's harder to work with. Okay, so when I say front squares means I look at this, the front. Okay, so notice what I'm shading. I'm shading those that are facing me right now. Okay, so I focus on working out the pattern for the squares first. So this question is a patterns with volume question, okay, which is a little bit tougher already. All right. Now, if you look at the pattern here, look at the squares first, the blue squares that I've colored. Don't care about the cubes first, yeah? All right, we focus on figuring out a pattern for the squares. Later, finding the total cubes easy because you can just times 5. All right. Okay, so first, let's look at the first figure. You notice it's 1 square. Okay. Second figure, it's 3 squares. Now, but instead of writing 3, right, I'll write it as 1 plus 2. Simply because of the way they are arranged. It's a 1 with a 2 below. Same for the third figure. Instead of writing 6 squares, I'll put it as 1 plus 2 plus 3. Then it's easier for you to figure out the pattern, you notice? Same for figure 4. 1 plus 2 plus 3 plus 4. I'm going from top to bottom layer, if you realize. Now, I hope you notice the pattern already. So long as your second figure is 1 plus 2, third figure is 1 plus 2 plus 3, fourth figure is 1 plus 2 plus 3 plus 4. So if you want to find out how many squares at the front face facing B in the 10 solid, it simply means 1 plus 2 plus 3 all the way until plus 10. So just look at the last number lah. If your last number here is 4 means plus 4. Here third means plus 3. Okay, so if it's 10 means last number is plus 10. So 1 plus 2 plus 3 all the way until plus the 10. Okay, now I know this is quite a bit to add. All right, there is actually a method that we used for matrix math. There's actually a method that we use to teach for adding like huge numbers like that in sequential order like this. Okay, but for now, I shall not dive into that simply because I think this question is only worth 2 marks if I'm not wrong, at most 2 marks. And since 1 to 10 are small numbers that we're still dealing with, it will still be relatively easy to work with the division. Okay, so if you just do your calculation, you should get 55 squares for this. Okay, otherwise, actually, like I said, matrix math, we're actually teaching you another method to efficiently add all these numbers, especially if you're dealing with big numbers. All right, but for now, for today, I will not dive into that. Okay, it's not really worth the marks here also. All right, so just do normal addition until 10, you should get 55 squares. All right. Now, every square constitutes 5 cubes. So notice that every square that I colored, right, consists of 5 cubes throughout if you span it towards the back. Okay, so simply what I just do next is, since every square behind it is 5 cubes, since there are 55 squares, that means I just need to take 55 multiply by 5 to get the total number of cubes. Okay, and there you go. That means 275 cubes. All right, so we're done with section A. We're moving on to section B. All right, let's continue with section B. So question 17. Mr. Chong had 15,250 ml of water in a pail. He poured all the water into an empty cubicle tank. Okay, so do take note the word cubicle comes from the word cube. So how much more water did he need to fill the tank to its brim? Fill to the brim means you want to fill it to the maximum. Okay, remember to express your answer in liters and milliliters. So right now, since they ask you how much more does he need to fill to its brim, this question tells us that this capacity, the tank capacity, is way more than the 15,250 from the pail here. Okay, so what he's doing is he transfer all the water from here into the tank. So what would be helpful is to find out the total capacity of the tank first. Okay, so that's my first step because I need to find the volume of the whole tank before I can figure out how much more water to fill up. All right, so capacity of tank, now since it's a cube, right, that means all sides will definitely be 30 cm. So that means your length is 30, breadth is 30, height is also 30. Okay, so unit of measurement, cubic centimeters, or you can say milliliters, both are the same. So you notice that the capacity is more than the 15,000 of water from the pill. Okay, so to find how much more, you just need to take the difference, just subtract. Okay, so this works out to be 11,750 cubic centimeter. Okay, now in this case, it's the same as ml, right? Okay, cm3 is and ml are the same thing. So read the question, express your answer in liters and milliliters. So 1 liter is 1000 ml. So this is 11 liters and 750 ml. Okay, so there you go. This will be the answer. All right. Okay, question 18. So the figure is made up of two identical rectangles. Length and breadth are all provided, 40 and 30 respectively. What is the parameter of the figure? Okay, so for questions like that, whereby the rectangles are arranged in a staggered arrangement, so we call this a staggered arrangement because they're not placed like side by side neatly. It's kind of like shifted, like this one is shifted downwards. Okay, so questions like that, whereby you have such staggered arrangements, normally I would like to use this cut and paste parameter concept that some of you might have learned it with us since P4. Okay, so what I'll first do is I will use one color to highlight all the horizontal lines that forms part of the parameter. So definitely this is part of the parameter. Like I said, I'm doing horizontal lines first, and definitely this is also part of the parameter. Okay, so this as well, and as well as this one. Okay, so those that I highlight in blue will be part of our parameter. So notice that you have 1, 2, 3, 4, 4 sets of 40, right? This is 40, 40, 40, 40. So 4 sets of 40 cm will be 160 cm. Now the next I will do is the vertical lines. Okay, so vertical lines I shall use a pink highlighter in this case. So notice vertical lines for your parameter will be this and this, and this. Okay, please do not highlight this one because this is definitely not even part of the outline of the figure. Perimeter means the outside of the figure. So this is not part of the outside. All right. So all the pink lines, we're going to do something with them. So notice that you have this little line that they have strike across like that 1 and 2 lines, right? It means that these two sides are equal. Okay. So since we know that this is 30, then for sure, I can confidently say this will be a 15 cm because 30 divided by 2. All right. So notice this 15 and this 30. This will be 30 and 15 as well. Okay. So that means 30 plus 15. Okay, this one together, you can times 2 because there will be another set of 15 and 30 here also. So left side and right hand side. Okay, so this will be 90. All right, and that's it. You can now add these two numbers together to find your parameter. So 160 plus 90, and that works out to be 250 cm. Okay, let's move on to B. So Rama folded a piece of rectangular paper along the dotted lines as shown in figure 1. Now it's a bit dark, okay, but the dotted lines are this and this. Okay, so basically he fold this downwards, he fold this triangle upwards so that it looks like this figure, the shaded part here. All right, so now we need to find the area of the folded piece of paper in figure 2. So we need to find this area. All right. So the approach is very simple. Okay. Simply, you can just find this triangle and this triangle. Once you found the area of these two triangles, you just need to take this away from the whole rectangle so that whatever is left is your folded area, is your folded piece of paper, I mean. All right. So generally, this will be the approach that we are going to work with. Okay, so maybe let's just call this triangle X and triangle Y for easier labeling purposes. So this will be X, this will be Y as well. All right, so notice you have these little lines again, okay, which means that you can safely say this will be 4 cm each, right? So 4 here and 4 here. Not an issue because 8 divided by 2. Okay, and also with this line here, this would then be 4 cm as well. Okay, so it's pretty straightforward then. All right, so we are going to find the area of triangle X first. Let's do that. So 4 and your 12 will act as the base and height. So half times 4 times 12. And next will be my triangle Y. So triangle Y here is 4, the base is 4, height is also 4. So half times 4 times 4. Finally, we can find a whole rectangle. Okay, the whole rectangle simply is length times breadth, which is a 96. So now you have to find the area of the folded piece of paper in figure 2. That means this shaded part in figure 2. You can just use the whole rectangle, minus away your X and minus away your Y. So it's very simple. Okay, so which will be 64 square centimeters. All right, so this is our answer. Okay, so we have come to the end of the paper revision. Thank you very much.